to a damped oscillation question here. So we got this example. A mass is vibrating at the end of a spring of force constant 225 newtons per meter. The figure on the paper shows the graph. I just drew it up here for us. Of the position x as a function of time t. At what time is the mass not moving? Okay, so the first part A, is really asking us, when is the velocity zero? So velocity equals zero when the position is equal to a maximum. So that would be at this initial point and then every second thereafter. Whether it's a maximum above or a maximum below, those would be those points where it's turning around, meaning the velocity is zero. Part B then asks us, how much energy did the system originally contain? Okay, so how much did we start with here? And so the energy is equal to the potential plus the kinetic energy. At this point, the kinetic energy is zero. Another way you could actually think about that, now that I'm thinking about it, you could also look for where is the slope zero to figure out where is velocity zero. Okay. So where that's equal to zero, we'll take that point, that's where it starts. And so I have 1/2 kx squared because it's a spring oscillating. And so I can plug in my 1/2 times my 225 times the original displacement, which was 0.07 meters. So I changed centimeters to meters there. And we should get an initial amount of energy here of 0.55 joules about. And so that's how much energy we start off with. And as we go, you'll notice that the next time it's down to 6. And so it just kind of generally loses energy as it goes. All right, part C says, how much energy did the system lose between t equals 1 second and t equals 4 seconds? So I just need to figure out how much energy did I start with at 1 second, how much energy did I end with at 4 seconds, and take the difference. So I'm just going to go ahead and use this equation. I can because at these 2 points the velocity is zero. So the energy evaluated at the final time would be at 4 seconds. That energy is 1/2 times 225 times 0.03 squared. The energy evaluated at 1 second was 1/2 times 225 times 0.06 squared. I don't have to worry about the fact that it's negative because it is squaring it. It really just cares how far am I displaced from equilibrium. I get these two numbers, I get about 0.4 and 0.1. So I get about 0.1 joules and I get about 0.4 joules, meaning that we lost about 0.3 joules of energy in this process. Where did that energy go? Probably heat, sound, deformation, those types of things is probably where that energy is lost to.